We often treat a broken heart as a poetic device, a dramatic metaphor for grief usually reserved for Shakespearean tragedies or romantic cinema. In the wild, however, poetry is a luxury that biology cannot afford. The core rule of the animal kingdom is that the drive for physical self-preservation overrides every other instinct. But a select few species operate under a different set of rules. For them, the loss of a mate can trigger a sequence of events that completely overwrites their own survival programming. In these cases, heartbreak is a measurable physiological event that results in death. We can trace this biological breakdown from a total collapse of survival behaviors to a neurochemical void that destroys the brain itself. Consider the shingleback lizard. They spend the majority of the year alone, navigating the vast and unforgiving terrain of the Australian desert. Every year, these solitary reptiles somehow find their way back to the same partner. Once reunited, they become inseparable, with the male staying in constant proximity to shield the female from danger. If one of them dies, the survivor stays by the body for days. They repeatedly nudge their partner's nose, seemingly attempting to elicit a response. During this time, the lizard ignores the biological signals for hunger and the immediate threat of nearby predators. The instinct to flee or feed simply stops functioning. The lizard's death is a result of behavioral abandonment. The grief is so all-consuming that the basic mechanics of staying alive are no longer a priority. Mute swans follow a different path to the same end. These birds spend years searching for a mate, eventually forming a bond that dictates their entire social existence. When a mate dies, the survivor enters high-intensity panic. They spend hours swimming away and charging right back toward the body in a bussing pose. This frantic behavior eventually gives way to an internal physiological shift. The initial shock of the loss triggers an extreme sustained stress response throughout the body. The swan will eventually leave the flock and find a secluded area. Over the next few months, their body slowly weakens under the weight of the stress until they eventually succumb. This represents a systemic failure. The swan doesn't die from a single moment of neglect, but from a long-term physiological decline triggered by the absence of its partner. The prairie vole provides the most extreme example of this bond. Their biology is hardwired for pair bonding in a way that is far more aggressive than most other mammals. Upon first contact, oxytocin and dopamine skyrocket in the vole's brain, flooding neural pathways. This surge creates a permanent chemical anchor to that mate, adjusting brain chemistry to constant high-level stimulation. If lost, this support vanishes instantly, leaving a massive neurochemical void it cannot fill. This sudden withdrawal causes acute brain damage. The nervous system begins to fail, leading to a rapid physical shutdown. For the vole, the end is catastrophic and internal. Their brain is so specialized for connection that it cannot survive the sudden severing of the bond. Across these species, we see a clear progression of physical damage, from suspension of the hunger drive to chronic stress cascades and destruction of neural tissue. It challenges the assumption that emotional attachment is a secondary trait, something that happens only after an animal's physical needs are met. For these creatures, the presence of a mate is a physical necessity. The bond acts as a prerequisite for health, as essential to their continued existence as a functioning heart or lungs. The biological cost of this deep connection is total dependence. An individual's survival is no longer an independent variable. It is tethered to the life of another.